So welcome back. In previous sessions we have seen two families under bipolar logic. Those are diode logic, diode transistor logic. Now in this class I would like to discuss another logic family under bipolar, that is TTL. TTL is transistor logic. That means it uses only bipolar junction transistors mainly in order to construct the different gates. Okay. There are three different configurations for TTL. Those are open collector output, totem pole output, and three-state output. Coming to open collector output, the output terminal of the final transistor is in open mode. That's why it is called the open collector. Let us see the circuit for the two-input NAND gate. Okay, this is the circuit acts as a two-input NAND gate. If you observe the final transistor, that is Q3, its collector is in open mode. Its collector is in open. That's why it is called open collector. Output from the terminal, that's why open collector output. Actually, open collector outputs configuration is just a modified form of the DTL, that is diode transistor logic. You know, in the diode transistor logic, you have four diodes. Two are the input diodes, two diodes at the inputs A and B, and two diodes in between these input diodes and final transistor. So all the diodes are replaced by Q1 transistor and Q2 transistor here. Okay, so the Q1 transistor replaces input diodes A and B and diode D1. Okay, do you remember this part of the circuit acts as a AND gate? This part of the circuit acts as a AND gate. Okay, so these three diodes replaced by a multi-emitter transistor. Q1 is called multi-emitter transistor because it has two emitters. You know, each and every junction of a transistor acts as a PN junction. So that's why instead of those three diodes, now we are using one transistor Q1, and the diode D2 is replaced by transistor Q2. Q3 is as it is. The transistor Q3 is similar to whatever the transistor you observed in the DTL logic. Okay, see, so this is the diode circuit replaced by transistors Q1 and Q2. Okay, then what is the purpose of replacing the diode D2 by Q2 transistor means, if you observe here the Q2 transistor in the emitter follower mode, it is in the emitter follower mode. So in the emitter follower, what is the advantage? The current gain is large. So that it drives more base current at the base of the transistor Q3, therefore its collector current is large. So whenever the collector current is large, therefore the sourcing current is large. When the source current is large, what is the advantage? The fan out is high. Okay, high fan out we are getting. That is the advantage of this TTL network. Okay, then actually you know that that diode circuit, how that network acts as a two input AND gate followed by transistor Q3, it acts as an inverter. So AND gate followed by NOT gate, totally it acts as a NAND gate. Okay, so though we'll see the operation of it. Okay, suppose both the inputs are 0 0 at A and B. Both the inputs 0 means we are applying 0.2 volts. 0.2 volts means the junction diodes are in forward biasing. Therefore at the base of transistor Q1, the voltage becomes 0.9 volts. By applying the KVL, the junction voltage is 0.7 volts plus applied voltage 0.2 volts. Totally at the base of transistor Q1, 0.9 volts we are getting. but that 0.9 volts is not enough to turn all transistors Q2 and Q3 because okay because here only 0.9 volts, that voltage is not enough. Okay, since to switch on these two transistors, almost here VB at the transistor Q3 base to emitter voltage 0.6 volts plus at the base to emitter of transistor Q2 0.6 volts plus from base to collector of Q1 assume also 0.6 volts, so around 1.8 volts you need at the base of transistor Q1 in order to switch on transistor Q2 and Q3, but now we are getting 0.9 volts only. That voltage is not enough to switch on Q2 and Q3, therefore the Q3 transistor is in open circuit. Okay, since it is in open, the output is become that is the output is across open circuit, hence the output is since it is connected to VCC through an RL external resistor, therefore output voltage is approximately 5 volts, that is considered as logic 1. Okay, so for 0 0 input, the output is logic 1. Similarly, so if another cases, if you take one of the input is 0 and another one is 1, the same action you can observe at the end. Okay, same around 5 volts voltage we are getting at Y, that is considered as 1. Okay, suppose if both A and B are logic high means applying 5 volts value at A and B, both the emitter junction diodes of this transistor Q1 in reverse biasing, hence at the base of the Q1 we are getting around 5 volts. Okay, around 5 volts. Now this is greater than 1.8 volts. Actually I said that to switch on Q2 and Q3 the minimum voltage at the transistor Q1 base is 1.8, but now the voltage is 5 volts. Now the voltage is 5 volts, that voltage is enough to switch on Q2 and Q3, therefore Q3 now is on, hence the output is almost output voltage is short circuited voltage, it is almost equal to 0, that is treated as logic 0. Okay, so this circuit satisfies the truth table of the NAND gate. Okay, so if you are not using this external resistor, what happens during logical high case, the output is open. So in order to pull up the output voltage properly, the external resistor to be connected between the output terminal and power supply VCC. Okay, so this is the operation of the open collector. So open collector, why we need to use the output put in open mode, it has some advantages. The advantages are we can get the wired AND gate application we can achieve, and another application is common bus facility. Okay, common bus, you can share the common bus. Okay, so let us see first of all the application of wired AND gate. Okay, that is without actual gate, just this junction point acts as a AND gate. Okay, so if you tie the outputs of open collector, if you tie the open collector outputs like this junction, that joint point acts as a AND gate. Okay, so let us see. Suppose this here two NAND gates in the open collector mode are connected, are used here. Both the gates outputs are tied here. Okay, the Y become is 1 when both NAND gate outputs are equal to 1, isn't it? If you, the output of NAND gate, first NAND gate is 1 and second NAND gate output also 1, then only Y become 1. Otherwise what happens, if any NAND gate output is 0, the output is a short circuited voltage. The output becomes a short circuited voltage. Okay, isn't it? Okay, so NAND gate output 0 means that Q3 transistor acts as a short circuit. Okay, since these two connected in shunt connection, if one is in short circuit means the total connection acts as a short circuit. Therefore, the output becomes 0. Okay, so now this junction point acts as a AND gate. How can you say if both the outputs are 1, then only output is 1? Otherwise, what happens? The output becomes 0. Therefore, this junction point acts as a AND gate. Okay. So now this circuit realizes an AOI gate. If you write the equation for it, this logic diagram, we are getting A plus B plus AB plus CD whole bar. AB plus CD whole bar, that is equal to AND or invert operation. Okay, that is the application of this open collector. And another application is with open collector gates you can share a common bus to transmit the data. Okay, so in this example I am taking 5 NOT gates. The first 4 NOT gates are in the open collector mode. Okay, so they are supplying data to the 5th NOT gate, for example. Okay, so here is the common bus, this is the common bus. Okay, now the outputs of all the open collector NOT gates are tied here. So you know the junction point, when the open collector outputs are jointed, that junction point acts as a AND gate. Okay, initially assume all the inputs are zeros, so that the output of first level NOT gates are 1. Okay, so all are at 1 means the AND gate output is 1. So on the bus line we have the logic value 1. Hence the output of the 5th gate is logic 0. Okay, suppose if you change the I4 value is 1. If you change the I4 value is 1, what happens? Its corresponding output becomes 0. Okay, since all these are in open collector model and they are connected in shunt. Okay, so the gate which gives the 0 output means there is a output transistor in short circuited way. So therefore all this shunt connection acts as a short circuit. Therefore on the bus line a 0 value is transmitted. Hence the output becomes y equal to 1. Because of the junction point acts as a AND gate, all inputs are ones except fourth one, its value is 0, therefore output is 0, hence y equal to 1. Okay, so like that. So here what we can understand is the other gate outputs must be 1 to transmit the selected input, in order to transmit select input. So in this example the selected input is I4, whereas other inputs are I1, I2, I3. So whatever the data you placed on I4, the same data can appear in Y, at the Y. Okay, so like that you can share. Suppose if you want to transmit I3 data, okay, you need to maintain the outputs of I1, I2, I4 gates at logic 1. Okay, so in that case the Y value equal to I3. Okay, like that a common bus is shared by different gates, right? That is the application. Okay, in next class you can see another model, that is totem pole model.